Imagine this, it's over 2,000 years ago. There are no satellites, no GPS, no computers, not even a simple telescope. How could anyone possibly measure the size of our entire planet? It sounds impossible, right? Like something straight out of science fiction. But one brilliant mind did exactly that, armed with nothing more than a stick, his own shadow, and an incredible amount of brain power. This is the story of Eratosthenes, the Greek mathematician who calculated the Earth. Eratosthenes was born in 276 BC in a place called Cyrene, which is in modern-day Libya. He was a true polymath, a librarian, a geographer, an astronomer, and a mathematician all rolled into one. He was the head of the great Library of Alexandria in Egypt, the most important center of knowledge in the ancient world. It was like being the CEO of Google and the head of NASA at the same time. He was surrounded by scrolls containing the accumulated wisdom of generations. One day, Eratosthenes read a fascinating report from a city south of Alexandria called Syene, known today as Aswan. The report said that on a specific day, the summer solstice, at exactly noon, the sun shone directly down into a deep well, illuminating the bottom completely. This meant the sun was directly overhead at a perfect 90-degree angle. At that exact moment, vertical objects like pillars or obelisks cast no shadow at all. This simple observation sparked a genius idea in Eratosthenes' mind. He knew that in his own city, Alexandria, this didn't happen. On the same day and at the same time, vertical objects in Alexandria did cast a shadow. He had seen it himself. Why the difference? He reasoned that if the Earth were flat, the sun's rays would hit both cities at the same angle, and both should have no shadows at noon on the solstice. The fact that they didn't meant only one thing. The surface of the Earth must be curved. This was a well-established idea among educated Greeks at the time, thanks to thinkers like Pythagoras and Aristotle. But Eratosthenes took it a giant leap further. He realized he could use this difference in shadow angles to actually calculate the circumference of the entire planet. His experiment was elegant in its simplicity. Here's how he did it. He waited for the next summer solstice. In Alexandria, at high noon, he planted a simple vertical stick, known as a gnomon, into the ground. As he predicted, it cast a shadow. He then measured the angle of that shadow, using basic geometry, the kind you might learn in middle school. He determined the angle was about 7.2 degrees. Now think about this. The sun's rays traveling to Earth are essentially parallel. So, the difference in the shadow angle between the two cities must be caused by the curvature of the Earth itself. Eratosthenes imagined lines drawn from both Syene and Alexandria, straight to the center of the Earth. The angle formed by these two lines at the Earth's core would be the exact same as the shadow angle he measured. 7.2 degrees. Why? It's a geometric principle called alternate interior angles. If you have two parallel lines, the sun's rays, cut by a transversal line. The stick in Alexandria extended to the Earth's center. The alternate interior angles are equal. He had the angle. Now he just needed one more piece of information, the distance between Alexandria and Syene. This was the trickiest part. There were no precise mapping tools. So, how did he get this number? He hired a bematist, a professional surveyor trained to walk in equal, measured steps over long distances. It was their job to measure roads for military and trade purposes. According to historical records, the distance was measured to be about 5,000 stadia. A stadion was an ancient unit of length, like a meter or a foot. But its exact length is debated by modern scholars. It was often based on the length of a sports stadium. Let's stick with the numbers Eratosthenes used. So, he had his two key data points, the angle of 7.2 degrees and the distance of 5,000 stadia. The rest was simple math. He knew that 7.2 degrees is 1/50th of a full circle, which is 360 degrees. If the 5,000 stadia distance between the two cities represented 1/50th of the Earth's total circumference, then to find the full circumference, he just had to multiply 5,000 by 50. And the result? 250,000 stadia. Now, converting this to modern units is where things get a bit fuzzy because of the uncertainty around the exact length of a stadion. but most scholars believe the stadion he used was about 185 meters. If we use that conversion, his calculation comes out to 46,250 kilometers. The actual circumference of the Earth, as we know it today from satellite measurements, is about 40,075 kilometers. That means Eratosthenes, with just a stick, his brain, and some hired walkers, was only off by about 15%. And some historians argue he might have been even closer, perhaps within 1% or 2%, depending on which stadion conversion you use. Either way, for an estimate made over 2 millennia ago, it is absolutely staggering. It's a monumental testament to the power of observation, logic, and the scientific method. He formed a hypothesis, designed an experiment, gathered data, and calculated a result. But the story of Eratosthenes isn't just a cool historical fact. It's a powerful lesson for all of us today. We live in an age of unprecedented technological advancement. We have supercomputers in our pockets, access to infinite information, and tools that would seem like magic to our ancestors. Yet, how often do we feel stuck or overwhelmed by the problems we face, whether it's in our personal lives, our communities, or on a global scale? We look at challenges like climate change, disease, or social inequality and think they're too big, too complex to solve. We assume we need some new, revolutionary technology, or a massive global effort to even begin. But Eratosthenes teaches us something different. He shows us that the most powerful tool we have is the one between our ears. He solved a planetary-sized problem by thinking creatively with the resources he had available. He didn't have a spaceship, he had a stick. He didn't have Google Maps, he had someone willing to walk a long way. He connected seemingly unrelated pieces of information, a sunlit well in one city and a shadow in another, and drew a world-changing conclusion. This is the essence of innovation. It's not always about inventing something new from scratch. More often, it's about looking at the world around you with fresh eyes, asking why, and connecting the dots in a way no one has before. It's about challenging assumptions and thinking outside the box. Think about the problems we're trying to solve today. How can we reduce plastic waste? How can we make our cities more sustainable? How can we improve mental health support? The solutions might not require a trillion-dollar research project. Maybe the answer is already there, hidden in plain sight, just like the curve of the Earth was hidden in a simple shadow. Maybe it's a simple observation, a clever combination of existing ideas, or a question that no one has thought to ask yet. Eratosthenes' legacy is a call to action. It's an encouragement to be curious, to be observant, and to believe in our own ability to reason. It reminds us that we don't need to wait for someone else to invent the perfect tool. We can start solving problems right now with the knowledge and resources we already have. We just need to apply a little bit of that Eratosthenian ingenuity. So, the next time you feel like you're facing an impossible problem, remember the man who measured the world with a stick. Remember the power of a simple question and a clever mind. The next great breakthrough might not come from a high-tech lab, but from someone like you, observing the world, thinking critically, and daring to connect the dots. What simple observations have you made that made you think differently about something? Let me know in the comments below. I'd love to hear your thoughts. And if you enjoyed this journey back in time and feel inspired by the power of human ingenuity, please give this video a thumbs up and don't forget to subscribe and hit that notification bell. We explore stories like this all the time, stories that show us the incredible potential of the human mind. Thanks for watching and keep thinking.